Okay, so this is lecture for section 3.1, and what we're going to be doing in chapter 3 is we're actually taking a look at logic. So this whole chapter is going to be all about logic and how do we work with the logic symbology and finding out whether statements are true or false. Okay, and so first of all, let's just define what logic is. We consider logic to be essentially the science of correct reasoning. And, this logic has its roots in philosophy, essentially. Aristotle, and there's many great philosophers that we can think of, but really Aristotle is the one that's most well known for laying the foundations of logic. And it took quite a while after he lived and after his work in order for logic to progress into the mathematical realms, to really put mathematical symbology to it and things like that. So that's what we're going to be looking at. Okay, the next thing that we need to define are statements. And when we're talking about logic, statements are the basic components of logic. And statements, essentially, they have clear meaning and are either true or false. Okay, so just to give you some examples of statements and some examples of non-statements. A statement might be something like, today is Thursday. Okay, which it is. At least at the time that I'm recording this video, today is Thursday. Okay, so that's something that's clear. It has clear meaning, and it has a true or a false, value to it. Versus something like this, a non-statement. That looks really sloppy, but that's my shorthand for non-statement. Might be something like this: how are you? So, that's a sentence that has meaning in the English language, but in terms of logic, it has no meaning for us. It's not something that we can decide that it's true or false, that it has some kind of true or false value to it. Okay. Okay, so those are, it's usually pretty clear whether something is a statement or not a statement. The next type of statement that we want to talk about are compound statements. Okay, and a compound statement is essentially a statement that it's essentially two statements that are joined by what we call a connective. And a connective is one of the words like an and or an or. Sometimes the word not is a connective, and sometimes if then statements are connectives. So what we say about compound statements is these may be formed by combining two or more statements. That's my abbreviation for statements. I just kind of leave out some of the vowels. Okay. And two or more statements, and we combine these using what we call connectives. So I guess I don't really need a period there. Using connectives, and connectives would be things like, these are words like and, or, not sometimes, and sometimes the if-thens. Okay? All right. So let's just take a look at an example. This is a couple of examples again from the book, the hard copy of the book. So we want to determine whether each statement is compound. Okay, so this is number 16. And the statement is, my brother got married in Copenhagen. Okay, well, that's something that clearly has either a true or a false value to it. And but it's not a compound statement. It is a statement, but determine whether this should be statement. Anyways, it is a statement, but it's not a compound statement because it's not joining two separate statements with the word and or. Okay, versus something like number 18 in the book says this. Mammy is younger than 18 years old, and so is her friend Emma. Okay, so something like that. We're joining two different statements here with the word and so we would consider that to be a compound statement. So this stuff is not rocket science today. This is just this is a setup section. We're doing lots of definition and just we're going to be going through some symbology, and this is just setting us up for the later sections where we're going to get into the bulk of logic. Okay. All right, so the next thing that we want to talk about is the negation of statements. Okay. And when we negate statements, some of this is very intuitive and some of it's not. So, when you try to negate something in our English language, if you're saying something is, then you would say it's not in order to negate it. And that's pretty straightforward. But, if you're dealing with a quantifier, a word that is all-inclusive, it's not necessarily that easy. Okay, so let's write this out first. What you're doing when you're negating is you're changing a statement. Okay, so you're changing a statement to one that has the opposite truth value as the original statement. Okay, so what that means is, if your original statement has a truth value of true, then when you change it, you want to change it in such a way that the resulting negation is false. So you're just changing it back and forth. Okay. Okay, so let me just give you an example here. Let's say I've got some statement, and then I want to talk about its negation. And I'm just going to give us something basic. So, for instance, Melissa, that's me, in case you didn't know your teacher's name. That's me. So Melissa is speaking, which I am. So that has a truth value of, true. If I wanted to negate that, then I would say Melissa is not speaking. Okay? And since I am speaking, that's false. So again, not rocket science, just changing, using some words to change this truth value. Okay, where this can get a little bit, I don't want to say complicated, but maybe not intuitive, is when we're working with quantifiers that are all-inclusive. So when we work with the words all or every, and sometimes the words, the words none or no, the negation of those is not what you would necessarily expect. Okay, so let's take a look at what we're going to be using here. So I'm going to give us some keywords in a statement, and then we're going to talk about the keywords in the negation. Okay, I don't know if you can see that. Keywords in a statement and keywords in the negation. I don't know. Okay, so if you see the words all or the words every when you're looking at some kind of a statement, to negate that, you're going to use the word some, and then you're going to use the words not. So you're going to say, if you say all flowers are blue, then the negation of that is some flowers are not blue. Okay? And I'll explain to you why this is after we write down some of the rest of this. So vice versa is true here. If the keywords in your statement are some and not, then the negation of that is going to use the words all or every. Okay? And if you are using in your statement the words none, if you're using in your statement the words none or no, then the negation of that is going to be the word some. And vice versa is true. Some is going to be negated by the words none or no. Okay, so let me give you an example here, and let's see if this will make some sense. Let's work with the statement, no cats have fleas. Okay, well, we could debate whether that's true or false. And, obviously, I guess we know that that's false. But anyways, if we're working with no cats have fleas, and we want to negate it, you have to use the wording, it is not the case that no cats have fleas, to see where this is going to go. So let me say this again. Your intuition here is probably going to be, if you have no cats have fleas, your intuition to negate that would be that all cats have fleas. Because if you have none and you want to negate it, most people think all. But here's what we're working with here. What we're trying to show is that it is not the case that no cats have fleas. Okay? So this is what we're doing when we're negating it, is we're saying, it's not the case that no cats have fleas. Therefore, some cats must have fleas. Okay, so the negation here is some cats have fleas. The problem with using the word all here to negate this is that, if no cats have fleas, and we're saying, it's not the case that no cats have fleas, then we know that some cats have fleas, but we don't necessarily know that all of them have fleas. That's not something that we can gather from negating no cats have fleas. Okay, so that's the reason why when we negate something like no or none, we just go to the word some and not to the word all. Okay. Another example would be, this is number 32 from the book. Everyone loves a winner. Okay, so that's the statement, and we want to negate it. So the negation of this, if we just look at our chart, the negation says some and not. But think about it. If you want to say everyone loves a winner, you're not going to negate it by saying no one loves a winner, because that's not necessarily what we know. What we know is that it's not the case that everyone loves a winner. If it's not the case that everyone loves a winner, then that means that some people don't love a winner. Okay? So the negation here would actually be some people do not love a winner. So that's using the statement having every and negating it with some and not. Okay? All right. I think there are a few problems on your homework. I'm not sure. I can't remember now actually if there are or not, but I think there's a few problems on your own homework that talk about negating an inequality. So just if we're talking about, for instance, the statement of p greater than 7, the negation of that is actually to flip the inequality sign. So negating p greater than 7 would actually be p is less than or equal to 7. Okay, and this is not a big part of today. The big part of today is working with the sentences and trying to understand how that relates to logic. Okay. Let's see. So next thing I want to do is show you the symbols that go along with some of these words. And the symbols are very important because obviously mathematics is a completely symbolic language. And so we need to have some symbols to be able to work with this stuff. Okay, so we're going to make a little chart here. And in that chart, we're going to talk about the connective. So the connective is the word that's joining statements. And then the symbol that goes with it. And then the type of statement that it is. I'm not really that concerned that you know the name for the type of statement. I'm more concerned that you know what word goes with what symbol. Okay? So with the word and, we use this symbol right here. And they refer to this as a conjunction. Oh, we need another